Good morning everyone, my name is Hasib and I will be explaining you the trigonometry unit in grade 12 functions. So the lesson I will be explaining would be trig identities, and in my group we have decided to do one component each, and I'll be doing the thinking part. So let's look at a simple trig identity question. So I chose this one. As you can see that the left side is cos x plus y plus cos x minus y equaling to cos x cos y. Now, the only thing that's different in grade 12 from grade 11 is a compound angle formula. So let's see how we can simplify it. So from previous units, you should know what this equals. We know that cos x plus y equals cos x cos y minus sin x sin y. And then we put in what the expanded value for this, which is plus cos x cos y plus sin x sin y. Pretty simple, but obviously, as you know, that when we're adding something, we try to collect the like terms. We see that that's a negative, that's a positive, they cancel out. The cos x cos y thing repeats twice, so we say 2 times cos x cos y. And just when we read that, we notice that the right side equals 2 cos x cos y. Hence proven that the left side equals the right side. So our first trig identity was quite easy. We just looked at the basic form. So this time let's try something a little harder. And instead of a compound angle formula, this question will have a double angle formula. So let's try this one. This is cos x minus sin x over cos x plus sin x equaling secant 2x minus tan 2x. Now these two are both double angle formulas. So since double angle formulas can be expanded, let's try to do the right side first in this case. So the right side would equal, as you can see, that secant is just the reciprocal of cos. So the secant of 2x would just be 1 over cos squared x minus sin squared x. So again, this is the things we know. It's just a little tricky that they use this, a secant instead of a cos. So you do minus 2 times the tan of x over 1 minus tan squared x. So this is just expanding this out. Let's try to do more work here, because we know that the left side just has cos and sine. This has a tan here, so let's try to get rid of the tan, which would be 1 over cos squared x minus sin squared x minus, let's try to make it sine and cos in brackets, which would be 2 times sine x over cos x. And obviously there's a bigger dividing here, which is 1 minus sine squared x over cos squared x. So as you can see that the 1 and minus sine squared x, it cannot be done yet because there's a cos squared on the denominator. So let's multiply the cos squared by 1. We go right side equals, again, I'm not doing anything to the first part because you can leave it as it is for now. Minus sine squared x. Subtract, we can go 2 times sine x over cos x. So obviously, because we try to make it the simplest way possible, we'll try to get rid of some things by multiplying them over cos squared x minus sin squared x. So since it was 1 times cos squared x is just cos squared x, and we just noticed that when we multiply it, some things cancel out. Good things happen. The right side therefore equals 1 over cos squared x minus sin squared x, and then we can subtract the 2 sin x cos x over the same denominator, which is cos squared x minus sin squared x. And obviously, if you know, you can just write them together. It doesn't matter, both ways are correct. The left side, however, is simple, but we're not able to make this equal that. So how can we do such a thing? I'll explain to you that in just a bit. Over cos x plus sin x. Now, just make a thought bubble right here. We know that, let's say we have a value j times 9 over 9. What would that equal? it will just equal j, wouldn't it? Why? Because 9 over 9, 10 over 10, 11 over 11, they're just equal 1. So, using that same principle, we know that we need the denominator to be a cos squared minus sine squared. How can we do that? Multiplied by cos x minus sine x over the same thing. Now, mathematically, that's not incorrect because we're just multiplying it by 1. There's nothing wrong with that. But using this will actually help us make left side equal to right side. So let's try. Let's try to expand it out. Multiply things together. Sine squared x, just doing the basic math here, divided by cos squared x. The sine and the sine cancel out, so you get negative sine squared x. Now, it's close, but it does not equal the same thing just yet. We notice one more step, which is that cos squared plus sine squared equals 1. Minus 2 sine x cos x over the same denominator. And just by multiplying the left side by 1, we have made it equal to the right side. So this equals what we just received for the right side, so this equals the right side. Therefore, left side equals right side. And this is our lesson for today.